Welcome back. So in this lesson here, we're just going to talk more about transformations of trigonometric functions, very similar to what we did. This time we're going to be talking about phase shifts and vertical displacements as well, or horizontal and vertical translations. So let's just quickly go through some of these. Most of these are pretty much review. First, at least 4 are pretty much review, and then the next one's down here. We'll talk about those. So we put a 2 in the front. That's very much like the A value here. So I'm just going to write down our typical standard form here. I'm going to use C's and D's instead because that's what we, for some reason, switch to when we do sine graphs and cos graphs. Use C's and D's rather than H's and K's. So this 2 is the A, so it does a vertical stretch. I'm going to write down the whole thing, vertical stretch, by a factor of 2 about the x-axis. Okay, and this one here is going to do the same thing, but this time it's going to be a factor of a third. About the x-axis. Okay, this one here, because it's inside the function, and if you want to, you could separate those two and say, rather than saying divide by 3, you could say that's 1/3 x. So my b value is 1/3 in this situation. So I have a horizontal stretch by a factor of 3 about the y-axis this time. Okay, now this 2 is inside. When they write it that way, when they don't write it without brackets, they assume that whatever is right after the sign is inside the brackets. So you see down here, if you go down further down to this one here, you can't assume the +7 is outside because they didn't write the parentheses here. So only things that are immediately after the sign are considered to be inside of the parentheses, and that 7 is outside. So like the sign, the 2 and the x are immediately after the sign. There's no plus signs or anything. So those, if there was any plus signs on this one here, then you would see, then those would be outside the function. But these ones here, you can see this plus is in the parentheses there. So these ones are inside the function. Anyway, horizontal stretch by a factor of 1/2 about the y-axis. Okay, and now we're going to get into these kind of funky ones. So these are the more horizontal, because this is inside the function. These are horizontal translations. Well, because they are in terms of periodic graphs, we don't talk about it as translations. We talk about these as phase shifts. So this is a 90-degree phase shift by, or phase shift, and then we also want the direction up by, whatever. Is it going left or right? Because of the negative, this is going right. Very key. This is also going to be a pi/3 phase shift. And this, because this is plus pi/3, this one's going to be going left. Okay. So rather than saying vertical or horizontal translation, now we say phase shift. And rather than saying vertical translation, this one, we'll say vertical displacement. So this has a vertical displacement of 7 units up. Okay, and this one here, I'm going to minus the 1 over. It's going to still be outside the function, but if I minus the 1 over, this is going to be a vertical displacement of 1 unit down. There we go. Now, all of those things, like, well, actually, the only thing that really I have to worry about is the d value, the moving this graph up and down, is going to change my range a bit than what it was before. It used to be just, if my midline's right here, my amplitude up and my amplitude down, that's my range. But if I move my mid-range line upwards or downwards because my D value there, so does my range. So my whole range is going to move up and down with it. Okay. So A does a vertical stretch. We're to figure that out. B does a horizontal stretch. A vertical stretch by a factor of A. B does a horizontal stretch by a factor of 1 over B, the reciprocal of that. And this represents the amplitude. The first does the amplitude, the A value does. It's supposed to be a D. And this one represents the period somewhat. It affects the period. It doesn't represent the period, but affects the period. But you can find the period using one of these two formulas here, because all they're doing here is they're taking the original period and they're timesing it by the reciprocal of B, which kind of just simplifies down to 360 over B, because 360 times 1 is 360. Now the horizontal phase shift is represented by the unit C. Don't know what this little space on it afterwards does, but if C is greater than 0, then it goes right. If it's less than 0, it goes left. And then up and down for the D value. And there's a little space here. I have no idea what they're doing there. Okay. Some things about this is that let's worry about the vertical displacement. I want to talk about the range. This will affect the range. I'm going to put that right there. Affects the range. Okay. And what I mean by that is that the range of the graph for this will be represented something similar to this, where you have your midline, and the minimum point is going to be where the midline is, which in this case is my D value, right? That's my midline, right? This is my midline because my graph was originally at 0. If I moved it up D or down D, my midline is now going to be where D is, what the D value. I mean, it's a horizontal line. So it's going to be where the midline is, and then I'm going to minus the absolute value of A. I'm going to minus the amplitude. And then over here, I'm going to go D for the top. I'm going to go up my amplitude. So my midline down my amplitude, and the midline up my amplitude would be my min and my max. So here I'm going to add my amplitude to it. So that would be essentially what this is, my min. This is my max, right? So that's how you determine my range using my vertical displacement and my A values. My domain is still going to be XDR. That's not going to change. Okay, so let's look at this and see what we could do. So we have I didn't start my timer on this one. That's the second thing. Okay, so my amplitude is 3. My max value, like I was saying before, is my D value plus my amplitude. My min value is my D value minus my amplitude. Okay, so my D value for this was, if you look at here, my D value is -1. My amplitude is 3. So my min value is 2. Oh, my max value is 2, sorry. Not min value. This is going to be this. I'm going to minus 3. So my min value is -4. There we go. I'm going to combine those two things together. I'm going to make my range out of this. So I got -4. I'm going to 2. That's good. My domain, XDR, that doesn't change. And my period, remember our period represented, because I can see a pi in there, so this is going to use the pi formula. So this is going to be 2 pi over my B. This is going to be 2 pi over 2. So my period is going to be pi. So B, this is my A. Okay, I don't have anything about phase shift in there. I'm going to put my phase shift down here. I have a phase shift. Why not plot it? My phase shift is going to be 2/3 pi to the right. Okay, 2/3 pi right. That's my phase shift. The equation of the midline, which is my D value, essentially, it's going to be my D value. It's going to be y is equal to, because it's an equation, it's a horizontal line, of -1. And my y-intercept, well, that's a bit trickier. You would have to either put this in your graphing calculator or just put, because remember to find the y-intercept, you make x equal to 0. Just make sure your calculator, if you're going to do it in your calculator, make sure your calculator's in the right mode. You do this in radians because I see a pi in there, so make sure my radian. So 3 times sine 2 bracket 0 minus 2 pi over 3 bracket minus 1. So I get a y-intercept of 1.598. There's more decimals to that. That's essentially what it is. And then we can actually plot this. Now, the reason I wanted the phase shift in there so we can plot this out nicely, because that's going to be important. The graph is going to be shifted sideways by 2/3 pi, 2 pi over 3. Right. Now, okay, so let's draw this out. I don't know if I can zoom. I'll have to zoom out of this ever so slightly so I can see it all. So what I'm going to do is I'm going to go step by step. Actually, I'm going to do the first thing. You could pretty much combine everything except for the phase shift all in one step. So the first thing I'm going to draw is where my midline is. So here's my midline. I'm going to draw my midline. Y is equal to -1. Now what I'm going to do is I'm going to draw the max. Where would the max be? And what we know the max is amplitude is 3. 1, 2, 3. 1, 2, 3. So my max here, this is going to be my max at the top. My min is going to be down here. This is where the min of my graph is going to be. So I can't go above or below those two. And then, because this is a sine graph, my graph, and this because I'm not going to do the phase shift right away, my graph starts on the midline going upwards. Okay, starts my midline going upwards. My period, it says here my period is 1 pi. So by the time it gets to pi, it's got to be doing the same thing. By the time it gets to 2 pi, it's got to be doing the same thing. It's got to be going upwards through the midline. Okay. Now it goes up, down, then back up. Okay, so by the time it comes back down, it's got to be going through the midline again, but downwards. The midline, but downwards. I'm just drawing some key points here. You probably draw one extra point over here if you wanted to, going downwards. It's going to hit the maximum point halfway between the two zeros. It's going to hit the minimum point halfway between the two zeros. Pretty symmetrical graph. So that's what this looks like. So I'm just going to kind of sketch this out. That's what this graph looks like without a phase shift. Oh, okay, I kind of drew that horribly. Hard to do. Okay, so that's what it looks like without a phase shift. So now what we're going to do, you notice that doesn't match the y-intercept that we have up there. What we're going to do is we're going to move this whole graph right 2/3 of a pi. You're going to take every single point and shift them sideways, right, which is right. Right, 2/3 of a pi. So I'm going to move this whole graph over 2/3 of a pi. That means I probably want more points. I'm going to put more points here as well on the negative side of this graph. Okay, so there's my graph. Okay, so I'm going to take every single point and move it 2/3 pi this way. So first of all, I got to figure out what 2/3 pi looks like on this graph. So 1, 2, 3, 4, 5, 6. So every single one of these is pi over 6. So that means this is pi over 3. Right, so this distance is pi over 3. So that means 1, 2, 3, 4 boxes is 2 pi over 3. So this here is 2 pi over 3. So 4 boxes is 2 pi over 3. So the whole graph has to move that distance to the right. So every single point is going to move that way. So I'm going to use a different color here. Let's pick a different color. This thing wants to select a color for me. Let's go green here. We're going to pick every single point and just move it over 4 boxes. So I'm going to start off with this point here. I'm going to move it over 4 boxes. 1, 2, 3, 4. So now it's here. Okay. The top box here. 1, 2, 3, 4. That's going to go there. 1, 2, 3, 4, that's going to go there. So right now what I have is this. Okay? Because maybe you have to do this in order. So you do your stretching first, you do your, then you do your translations. So do my translations last year. I did the up and down translation already because that was just easier to do. So then you take another point, and go 1, 2, 3, 4, right about here. This is going to go down more. Oh, and this is going to go from here, 1, 2, 3, 4, right here. So there's that graph, and then I'm going to go backwards here. So this point here moved over 4, 1, 2, 3, 4, and then this point's going to move over 4, 1, 2, 3, 4, right about there. There's some point way over here that's going to move over 4. That's going to end up being right about here, and hopefully I get 1.5 or 1.6 right about there. Yeah, that looks about right. And then this is going to go down to right about here. And this is going to keep going this way. There we go. So the green graph is the graph that we have here. So we took the whole pink graph there and we just shifted it all 2/3 to the pi, right? Which essentially, if you just look at that now, that is the same as moving the whole graph back 1/3 of a pi. Like you could have moved it left 1/3 of a pi and you got the same result. That's a different story. We're going to talk about that, how there's multiple answers to get to the right spot. But that's our shift there. Seems like it worked pretty good. Yeah, looks good. Pretty tricky question. Okay, so I'm going to stop there just to kind of minimize the size of this video. Really didn't do too much on this one, right? And then we'll talk about more of these and some trickier ones like here, the 4 hasn't been factored out properly. And then we'll talk about, if I have the graph, can I go back? I'll see you in the next video.